Okay. Hello guys. So we're going over the review of square root functions, the test review. So this is the review sheet that you have received in your class. Let's see. Let's solve a couple of problems. I'm not going to solve every problem, but I'm going to give you an idea of how each problem should be worked out. So usually the test review is a good way to start, whether to test yourself how confident you are for the test. So let me help you with that process. We have done most of these questions in the class, but we'll go over some concepts. So the first question here is about inverse functions. So it's saying the following graphs are of f of x and g of x. And never mind certain typos, but we need to find a graphical way of finding the inverse of f of x and use the set or interval notation as asked for to write the domain and ranges of the original function and the inverse function. So if you see the first question, he's saying we need to find the graph of the inverse. We need to state the domain and range of the original and g of x, which is the inverse. So let's see what happens. The first question here, looking at the graph, you need to plot the points first of the original graph. So I see that the first point is at -6 and 2, -3 and 6, 1 and 2, and 3, 4. So this is my coordinates for the first graph, and to find the inverse of it, we just flip or switch the x and y values. So the domain of f of x becomes the range of f inverse of x. Remember how we write the inverse function? Mathematically it's f -1 on the top as an exponent, but we say it as f inverse. So please do not say f -1. You should be saying it as f inverse of x. So all you have to do is make the domain of f inverse of x the range of f of x. So let's switch that. So all these 2x, 2, 4 come here, 2x, 2, 4. And all x values now become the y values. So we have -6, -3, 1, and 3. All right. So we try to plot this on the graph. So we have 2 and -6, 1, 2, 3, 4, 3, 4, 5, 6. I think it's here, this point. And 6 and -3. This is my 6 and -3 is here. 2 and 1, 2 and 1. And the last one is 4, 3, 4, 3. I'm sorry, right here. So now, oops, something's happening. Let me take my pen again. Hold on. So we have here, and the next one is here. I'm sorry, it all screwed up here. Okay, never mind the graph. Let's see if I can erase this mess. Let me erase this. Okay, we'll try to draw it again. Sorry about that. So this is starting here, it'll go and then come back. So it's kind of, you can draw it by yourself. You're capable of doing that. Right now, let's find the f inverse of x. I'm sorry, the domain and range of f of x. So the domain for f of x, see the minimum point is 2. I'm sorry, the domain is here. Minimum point is -6 and the max is 3. So you say, you write your x. So this is your minimum point, -6, and your maximum point is a 3. So when he's asking for a set notation, for example, how would you write this? This is an inequality notation. Inequality notation. I want it in set notation. All you have to do is draw the floor bracket, say x belongs to R, such that, and you have this negative 6 less than x less than 3, and close it. This is your domain, by the way. The range would be y belongs to R such that the minimum value is 2 and the max is 6. So y is lying between 2 and 6, and close it. That's it. Now for f inverse of x, your domain becomes the range of f of x. So it's just the same thing. You just change your x, switch your x and y. So this x belongs to R such that x lies between 2 and 6, and this the range y belongs to R such that negative 6 is less than or equal to y is less than or equal to 3. Alright, so this is the first question. I'm not going to do the second one, the B part here for g of x, because this is this is for your practice. Make sure you know the interval notation too. I'm not dealing with the interval notation at this point. Let's look at the second question now. So he says, consider this function g of x is equal to square root of x minus 6 plus 3. Sketch the graph and represent this function. So to give you a hint here, look at the main function. This in vertex form would be g of x is a times square root of x minus h plus k. Remember that? So the g of x is same as this one. So the idea is to compare this function with this so that we can get the starting point. The starting point is hk, and in this case it is 6 and 3. So making that as a starting point, I recommend you draw a small table of values. So and you have x and 3, x and y. You have 6 and 3 as your first point. Figure out what could be the values. Just try two other points. I chose 10 as my x, so it will be easily worked out. 10 minus 6 is 10, sorry, what am I saying? Yeah, 10 minus 6 is 4, and square root of 4 is 2, so 2 plus 3 is 5, so your y is 5. So you choose your x values because x is your independent variable, and the other value I chose is 15, and you get a y of 6. So using this, plot your graph. Your starting point is at 6 and 3, so which is right here. Your next point would be at 10, right here, 10 and 5, which should be here, and 15 is in between these two squares, so and 6, so it should be somewhere here. So when you draw the graph, your starting point is this, and your square root function looks like this. My curve is not perfect, but that's how you do it. Describe the transformations on the parent function to create the g of x. So this is it. So first you sketched your graph. The next point is describe the transformations. I see that the a is equal to 1 when you compare this with the vertex form. A is 1, so there is no reflection, there is no vertical stretch or compression. So the next point is x minus 6 here, which is the graph moves horizontally. We all teachers here at Algebra team, we want you to use these words, horizontal translation. We don't want to see arrow marks saying up or down, left or right, or just say up, moves left. No, we really want to see these words, horizontal translation to the left, in this case it is right, 6 units. And also, I'm not going to write it here, but you have a vertical translation 3 units up. So what is a domain and range? Look at the vertex here. Domain and range is H and K, which is, I'm sorry, you can get that information from the vertex. Here the vertex is the start point or the end point, which is 6 and 3, which we have written here. Looking at this, we can easily define our domain and range. Also, we have our graph. So we see that this is an increasing function, and for x value starts at 6, and oh, I have written it. So this is my curve. Okay. My x starts at 6, so you need to say in interval notation this time. Domain is 6, open closed interval 6 to open interval infinity. It's going forever on the x direction. It's an increasing function. And y, the domain starts at 3 and goes in the positive direction. So range is closed interval 3 to infinity open interval. It's asking find G inverse algebraically. So this is where I really want you to focus, guys. So I'm going to write a little bit on this graph, so because I need space to work with. So we have g of x is square root of x minus 6 plus 3. Now the first step is to change g of x to y, replace it. So this is square root of x minus 6 plus 3 plus 3. And 3 is the outer number which is added to the square root. So we have to get rid of that. Oh, sorry, because before that we need to switch x and y. So we switch x and y. And we need to, the third step is to solve for y. So in the process of solving for y, we need to first subtract 3 on both sides. So this becomes x minus 3 is equal to square root of y minus 6. Now you have to square on both sides to get rid of the square root. So this becomes x minus 3 whole squared. This is minus 3 is equal to y minus 6. Now add 6 on both sides, plus 6 and plus 6. So your function actually becomes x minus 3 whole squared plus 6 is equal to y. Now replace y with g of x. This is your inverse. Okay, this is your inverse function. The next question says determine, forgive me for this, somehow the word is trying to insert this as an image, never mind. So where are we? We are, yeah, determine the domain and range for the inverse function. I will leave that to you. This is a quadratic because the inverse of square root is a quadratic. So try to figure out the vertex here. It is the same thing, 3 and 6, but this time your domain and range will change. Your domain will be all real numbers because it's a quadratic function, and your range will change from 6 to infinity. Okay, I'm just saying it, I'm not going to write it here. But here he says explain how to find domain and range of the inverse of a function f inverse of x if you know the domain and range of the function f of x. So remember the earlier problem, we switched x and y values. So what happens when we say switch x and y values? Aren't we just switching the domain and range? So the domain of f of x becomes the range of f inverse of x, and vice versa. So you need to write that in words here when you're asked the same question on the test. Okay? I'll end this video here. This is part 1 of the video, and the next part we'll try to solve some more questions. Thank you for watching.